Welcome to Live from Plato's Cave. I am Mario Veen. Plato's Allegory of the Cave is the most famous story of Western philosophy, but it has been interpreted so many times that we might almost forget that sometimes a cave is just a cave. So what can we learn when we think of the cave and the surface of the earth and the sun in Plato's allegory as actual phenomena that we can study? In this episode, I invited geologist Marcia Bjornerud to give us a tour of Plato's cave. Whatever you think of the situation of the prisoners in the cave, it's clear that the prisoners themselves do not see their own situation. They do not regard themselves as prisoners. Only after ascending to the surface and returning into the cave do they see the situation they used to be in. But when they see their situation, they're no longer in it. You could say that in a way, we are prisoners of the present, of a three-dimensional world that seems like it has always been this way and will probably always be like this. But in this episode and the next, we are going to look at how we can think in 4 dimensions. Next month we will look at our relationship to our human past and our experience of the human present. But today we will look at deep time, or the way the non-human past is shaping the human future. The part of the Earth that we experience right now is such a tiny fraction of the whole Earth. If the Earth would be a peach, the solid surface that we live on would be as thin as its skin, and the fuzzy layer represents our highest mountains and deepest ocean trenches. And if you extend your arms to your sides right now, and the length of your arms represent the time since the Earth was formed, then our human history is only as long as the white part at the end of your fingernail. I'm a total amateur when it comes to geology, but one of the things even I knew is that if we dig into the earth, we encounter different layers, and each layer represents unimaginable time spans of millions and millions of years. Geologists study, among other things, layers in which they can read about the past. What did the earth look like at the time? Who lived there? What was the climate like? What was the cause of a disruptive event? In combination with other scientific methods, geology has established that the Earth is approximately 4.5 billion years old, and that there have been 5 major environmental crises in its history. One that almost everyone knows about took place 65 million years ago, when the dinosaurs went extinct. But even though at that time 3/4 of all living species died out, it ranks only as the 4th worst crisis in those 5. At one point, 250 million years ago, 95% of all species went extinct. Oh yeah, and there was this time when the Earth was an uninhabitable snowball for 200 million years. Well, what I find most amazing about this is that we are around to study the layers that reveal those events in our planet's history. In other words, life on Earth recovered each time, and now we are here. What kind of incredible planet do we live on that no matter how extreme the changes, she always re-establishes periods of balance? In her book Reading the Rocks, an autobiography of the Earth, Marcia wonders what our geological layer will look like when it is studied by a geologist millions of years in the future. Whether we will still be there to witness it depends on what we do right now. And the current state of our planet looks eerily like the circumstances just before some of those crises. In episode 3, we discussed Mieke Bal's film It's About Time, Reflections on Urgency. In this short film we see Cassandra, a woman who received the gift of being able to foresee the future, but also the curse of never being believed. Mieke compares her to Greta Thunberg. I have so much respect for Greta. At the same time, I also understand why people have the urge to dismiss her, to even ridicule her, and to switch off the television when she holds one of her fiery speeches. Her message is very confronting. And it's much more comfortable to flee back to our comfortable seat in the cave, where life is perhaps not always easy, but at least it's familiar. Greta says, I don't want you to listen to me, I want you to listen to the scientists, and I agree with her. Most of the benefits we enjoy every day, like the device on which you are hearing my voice right now, have come about through insights about the physical, chemical, and biological reality that we live in. So if we want to know more about the state of our planet, who better to speak to than our guide today, who spent her life reading the autobiography that the Earth has written in her rocks. Marcia Bjornerud is Professor of Geology and Environmental Studies at Lawrence University in Appleton. Her research focuses on the physics of earthquakes and mountain building, and she combines field-based studies of bedrock geology with quantitative models of rock mechanics. She is the author of Reading the Rocks, the Autobiography of the Earth, which I mentioned already, and a contributing writer to the New Yorker science and technology blog Elements. Her most recent book is called Timefulness, How Thinking Like a Geologist Can Help Save the World. In Reading the Rocks, Marcia writes that the only autobiography that was transcribed without any self-interest or self-consciousness is the life history of Earth, which has literally been written in the rocks. It is the only text that should be mandatory for every earthling. Because we are destroying the roof and destabilizing the heating system of our beautiful home, our only shelter, without having taken the trouble to study the construction details of this house. In Timefulness, she writes, "The unprecedented scale of human changes to the planet's topography is one of the arguments for the concept of the Anthropocene, a new division of the geologic timescale marked by the emergence of humans as a global geologic force. We are literally changing the configuration of the continents and remaking the world map. But does this matter on a planet that has seen so many geographies, constantly erasing old worlds and replacing them with new ones? It doesn't to the Earth itself, which will eventually remodel everything according to its own preferences, either gradually or catastrophically. Over human timescales, however, our disruption of geography will haunt us. Soil lost to erosion, coastal areas claimed by the sea, and mountaintops sacrificed on the altar of capitalism won't be restored in our lifetime. And these alterations will set in motion a cascade of side effects that will define the human agenda for centuries." Marcia, thank you for joining me.
It's wonderful to be here, Mario.
And thank you for being our guide in Plato's cave, which now is quite literal. Have you done any cave excursions or something like that in the past?
I have, although I have to admit to mild claustrophobia. Okay. I much prefer to look at rocks under the sunny skies. But caves are fascinating because they give glimpses into this world that is otherwise inaccessible.
I read 2 of your books in the past weeks, and it was just so fascinating, this experience. And one of your books is called Timefulness, How Thinking Like a Geologist Can Help Save the World. What is timefulness?
It's a sense that we live in geologic time, that there's a continuum between the deep past and the future. And it's a deliberate counterpoint to the idea of timelessness, which we sort of think of as an aspiration. I think since the time of the Greeks, the idea of the eternal and the unchanging has been held up as a kind of perfection, when in fact, nothing is unchanging. So timefulness is embracing the idea of an evolving world that includes the fact that our own version of the world is temporary, and it hasn't always been this way, and it's not going to be like this in the future. So coming to terms with that, making peace with our place in geologic time.
When you speak about the time of the Greeks, that's the time that the Allegory of the Cave was written. It's about almost 2,500 years ago. That's a long time, 2,500 years ago. Or is it? How do you see that as a geologist?
Well, of course, I'm human. And as a human being, I can say, yeah, that feels like a long time. That's generations and generations ago. As a geologist, it's 2 seconds ago. So that habit of moving through time is really the way geologists think. The capacity to, in the mind's eye, visit other times as if they're places is really what I I'm talking about when I'm talking about timefulness. So Plato, as far back in time as he may seem to us in the 21st century, is really a contemporary.
And how can, because the numbers become so big and, 10,000 years, a million, a billion, what's the difference, right? And I always think of the Earth as a Mother Earth. And I know it's not polite to ask about the age of a lady, but how old is she?
She is a very venerable 4.5 billion years old.
4.5 billion years.
10 to the ninth. So yeah, I think in Britain, billion might mean something different, but 10 followed by 9, or 1 followed by 9 zeros, 10 to the 9th. Mm-hmm.
And human beings are 1 followed by 4 zeros.
Something like that. Yeah. Modern humans, 100,000 years or so. Yeah.
So how could we visualize this? I'm sure as a geology professor, this is what you do every day.
Right. And I think we get habituated to talking about millions and billions of years. I'm not sure that we can ever say that we really understand what that means. But I think in studying geology and understanding the narratives of the geologic past, what has happened in those times, that's how you begin to come to grips with what they mean. Mountains growing and being erased again by erosion, continents moving. When you get a sense of the processes that happen at these different timescales, then you begin to understand what they mean. So to me, it's not just the numbers, it's the narratives. And there's another Greek concept that I think is useful. It's the distinction between chronos, which is just the raw quantification of time, and kairos, which is time within a narrative. And it's the latter, that kairos, that I think is the beginning of understanding of geologic time. What has happened in those millions and billions of years? And then you begin to enter into the logic of the Earth and its story. But the numbers themselves are just kind of alienating.
Mm-hmm. And so in your other book, which I know the English title is Reading the Rocks, but in Dutch, the title is simply Earth, an autobiography, which I really like, because usually people write an autobiography about their own lives from, the time they can remember until, the time they write that autobiography. So how did you come to write an autobiography of the Earth?
Well, I guess in the English title is Reading the Rocks, the autobiography of the Earth, with the implication that the rocks are the autobiography of the Earth. I wouldn't be presumptuous enough to think I could write the Earth's autobiography, but I've read the autobiography, which is the rocks. Yeah. So
you're transcribing or translating what you read in the rocks.
Exactly. That was my role, to do my best to convey to people who don't speak rock what the Earth is saying.
So I'm really excited about this, about your willingness as well to tell the story kind of in the narrative that we use in this podcast, which is the allegory of the cave. Why don't we start? Because, if you're claustrophobic, we should probably not spend too long of a time in the cave. How do you read this situation of the prisoners, as Plato describes it?
Well, of course, I've been familiar with the allegory for a long time, but listening to it again on the first episode of your podcast, I was struck by the question of who is the imprisoner at the beginning? Why are these people imprisoned? And if we take the allegory as speaking of education, it's, of course, general ignorance is the thing that imprisons us. So if I think about it in the development of the geosciences, in the West anyway, the thing that impeded our understanding of the Earth was largely religious dogma. And the idea in particular that the Earth was no more than a few thousand, perhaps 6,000 or 7,000 years old, based on some very literal-minded reading of the Bible. other cultures didn't seem to have that very limited view of the age of the Earth. And it's always fascinated me to think of an alternative evolution of the geosciences in which maybe insights into reading the rock record had come primarily from China or from India rather than from the West. And modern geology did get started in the West, which was shackled and imprisoned by these religious ideas. And it took a long time to break out of those. People used rocks for practical purposes, but there doesn't seem to have been the attempt to read them as a narrative in the East. So when I was thinking of the allegory of the cave and the development of our understanding of the Earth, I had to conclude that at least initially, the imprisonment was the blinkered view of how the Earth had come to be that was based on Judeo-Christian texts.
Mm-hmm. So perhaps they're in the cave, they're looking at a screen. The previous episode was about film, so it would be a screen. I was thinking it could be the surface of the Earth because right now we are both on the surface of the Earth. Yeah, if you just live here and you don't know so much more, then you just think that's all there is. But that's only a very tiny part of the Earth.
Right. And so I often say that geology is really a lens through which we can see the Earth, not just in 3 dimensions, but in 4 dimensions, which includes time. But most of us do live on this kind of very shallow plane, which is just a 2-dimensional shadow of this much, much richer story. So, and in particular, when people perceive that the way the Earth is now is the way that God had created it, that was something that just made it impossible to imagine the large-scale, long-term processes that have actually shaped the way the Earth has come to be the way it is. And some of it is just scale too. The Earth is so big; it's all around us, and certainly in pre-modern times, it was very difficult to zoom out far enough in the old sense of zoom, and get any kind of perspective. So there was a lot of background work that had to be done, maps to be made, and places to be documented before any kind of larger conception could be formed. So in teaching geology, I realized that one of the metacognitive skills that is very, very challenging for students to develop is the habit of zooming in and out of spatial scales, as well as temporal scales. When you're looking at a rock in a particular outcrop, and then how do you make an inductive leap that this represented an ancient island arc system of volcanoes that were in the middle of the ocean at some time.
Yeah.
It's that sort of thing. And that just developed, that required centuries of arduous work at the small scale to little by little build up any kind of conceptual map of the globe.
I really love to follow the way discoveries in geology happen, because even someone else called this thinking moves. Like, how do you, because you are on the surface on the Earth, no one has been inside the Earth, and still we know so much about it, but where do you even start? You show some really big leaps. Speaking about stones, in philosophy, stones are often used to represent the real material, like actual world, like the cold stone or as hard as stone. And there's even a famous story about Johnson, who heard about Bishop Berkeley's philosophy of idealism, where he says that there's, everything is an illusion. There's no material world. And what he did is he kicked a stone with his foot and he said, I refute it thus. So rocks are always there, whatever else you can think about the world, rocks are solid, they are real, they are simple. But then you start to read them. It reminds me a little bit of the episode with Mieke Bal. We spoke a little bit about when you're in a museum and you're in front of a painting. sometimes you move further away from the painting, so you see the whole picture, but you also have to zoom in. But the moment you zoom in, you lose the overview, so you have to constantly keep moving. And one of the ideas that just baffled me is that apparently for you, stones can be seen as a liquid, not like if you, of course, lava and magma, I can imagine that, but you say that stones, just like the stone that I can pick up from the floor and hold in my hand, you regard them more as a liquid when it's in the mantle of the earth?
That's right. Yeah. My field of structural geology is largely about how stones are fluid, not liquid, but things that flow over long enough timescales, at least if they're at moderate to high temperatures. Yeah, so absolutely. Stone is very animate and, contrary to its reputation, not particularly inarticulate. If we learn to listen to stones, they have much to say. But I love the role that stones and rocks have played in philosophy as kind of truth tellers or reality checkers. Yeah.
And for you, they're actually more fluid if you think in 4 dimensions.
Mm-hmm. If you're patient enough.
And I love how in your books you use a lot of analogies. And what I really appreciate is that you use an analogy, but you also show the limits of the analogy. They don't become simplified. Like one of my favorite ones is you talk about that there's a balance on Earth between the forces that build mountains and the forces that erode. So like on Mars and other planets, you have very high mountains, which you couldn't have on Earth because we have erosion. And you compare this to a barber that cuts the hair of a customer as fast as it grows, sorry. So the hair remains as long. Just out of curiosity, what is your favorite analogy? Because I just imagine you come up with these analogies, and which one was your favorite that you're most proud of?
That one I always laugh when I think about it. And it just always pops into my head whenever I see the giant cones of eroded sediment in the Indian Ocean that are clearly derived from the growing Himalaya. It's just so obvious. So I don't know, as a teacher, I have to kind of come up with these on the fly, and sometimes I've reappropriated them in my writing. But I think, again, finding ways to humanize and make familiar some of these concepts that can otherwise be such abstractions is critical to reach the brains of earthlings who aren't familiar with these kinds of timescales.
And are they just for the sake of teaching and science communication, or are they also part of your work? When you are doing your actual science work, do you also use analogies to think?
I guess to some extent. I realize that I have a kind of relationship with different rock types. Some of them I feel very fond toward. Others, they just don't seem like my kind of rock. I can respect them without feeling intimate with them. And so to some extent, I suppose I'm anthropomorphizing rock types. It may be an aesthetic thing. I'm not sure. An example, in this part of Wisconsin, we have a lot of carbonate rock called dolostone, which is a marine sedimentary rock similar to limestone. And I am very grateful to dolostone and limestone for sequestering billions of years worth of volcanic carbon dioxide in mineral form. But I find the stone boring. It doesn't really have a lot to say. It's usually kind of recrystallized. And so much of the whatever it once represented has been blurred and erased. So I just find it a kind of inarticulate rock that I just don't enjoy spending time with. But I appreciate it very much for its role in keeping the climate stable. So in that sense, I think it's a natural human instinct to kind of give agency to things in nature. And I think that's okay. It helps us feel embedded in this system. And so I use these analogies quite shamelessly, certainly in teaching and speaking with the public. It's not really allowed in scientific writing for other scientists. But I have to think that many natural scientists who spend time embedded in these systems do actually think this way.
Yeah, I was thinking, for instance, about one of the developments in geology was the idea of actualism, where you try to explain what you see now, geological processes. You try to explain geological processes in the past by finding maybe an analogy with what is happening now. If you see, for instance, the effect of the wind on a beach or the waves on a beach, you could say, well, maybe perhaps mountains work like that too. So that's what I was thinking of. And metaphors like, is the earth a living machine or is it an organism? Or
yeah, well, so this idea of actualism or uniformitarianism is the literal bedrock of modern geology. If you don't begin with that idea that the present is the key to the past, then there aren't any rules in a way for making inferences. So that is usually identified as the starting point about 250 years ago or so of modern geology, this idea of uniformitarianism or actualism, which is a kind of more strict uniformitarianism in the idea that we can only invoke the processes and the rates of processes that we can see today. And that's traced to this great Scottish Enlightenment thinker, James Hutton, who interestingly did use analogies of Earth as a kind of cyborg almost, a living machine, had aspects of an organic being, but also kind of a mechanical thing that was powered by some great internal heat engine. And yeah, I'm fascinated, especially having been in this field now 30 some years, long enough to see paradigms shifting slightly, how these subconscious metaphors operate even in the nominally objective world of science, that there are these kind of Jungian metaphors, forms that we invoke or that come in and out of vogue that I think influence scientists more than they would like to admit.
Just before we move, we should probably start to climb up to the surface. But before we move on, if you see geology as a person, is it a baby or a toddler or a PhD student or an old lady?
I think it's a late bloomer. It's someone who had an early promising childhood and then spent a lot of time due to circumstances stuck for a while in a dead-end job, maybe. And more recently, just in the last 30 years, maybe a bit longer, has come into its own and is now just freed from earlier limitations and discovering its true strengths. So, it's a science that's been around, but it had this doldrum time, which I think is really tragic and which lingers in the public reputation it has, I think. And people don't realize that now geology is in kind of a golden age of real nuanced understanding of the Earth through time. And that message has not gotten through, at least certainly in this country, to the general public. So yeah, late bloomer.
Mm-hmm. So when we go to the next stage, we make the ascent upwards, and Plato describes how we're blinded by the fire and we're going up. And I think Plato's idea is to get the prisoner up to the surface as fast as possible. But I imagine you would be very interested in all the layers that we encounter along the way. And how do you see this part of the allegory?
Well, to me, this is this interesting time of Hutton, the sort of Enlightenment time, where there was a glimmer of the great antiquity of the Earth. And there was a moment in the late 1700s through about 1850 when geology was kind of like space exploration is today. I think it was captured the public's imagination. It was in this time of flowering. Hutton, famously at an outcrop in Scotland, recognized that the Earth had to be far, far older than the biblical 6,000 or 7,000 years. And this captured the minds of great thinkers across the continent. And so that was the beginning of working out methodology, including uniformitarianism, how to put together the sequence of rocks that represented this great expanse of time. So coming out of the cave was literally, geology really did begin as stratigraphy, which is the study of layered rocks.
So the what we see at the surface is actually usually the youngest. And
usually.
Then the deeper you go, the older you would think you would get, like, but it's not like the layers of a, if you would cut a tree, the more you would go towards the center, the older it would be.
Right. Yeah. So that's generally true if those rocks are rocks that were laid down at the surface of the earth. It's not true if we're speaking of granites, for example, which are magmas intruded from below into pre-existing rocks, or in cases where there's been deformation of rocks that has disturbed and tilted, folded the rocks. So then it can be more complicated. But in places where the rocks are simply flat lying, yes, the youngest materials at the top and the oldest at the bottom. But the really difficult thing was that it became clear quite early on that no single place had a continuous record. And so at any given place, you just have a little fragment of the Earth manuscript. If we come back to that, it's one page. And so you might be able to work out the chronology at a given place, but then you go somewhere else, intervening area where there's no outcrop. How does the story at this other place match up or not with the first place? And so that was the problem. Initially, there was no way to know the global page numbering system. And one really amazing independent thinker who was a canal builder in the south of England, William Smith, started paying attention as he was excavating canals to the strata and the fossils in the strata in the south of England, and realized that the fossils were very consistent in the sequence in which they occurred. And that became the first tool for beginning to correlate fragmentary records from place to place and the beginning of a global timescale. And initially, he and other people thought that the rocks of a given age would have been the same all over the earth, which is kind of a funny idea now, that the chalk of the Weald in Britain and France is not a worldwide layer. The chalk is a major continuous Cretaceous layer we recognize now, but not every place on Earth has the same rock in the same time.
But what's the youngest naturally formed rock? How old is it?
Yesterday.
Does it take so quickly to form rocks?
Well, we were talking earlier about the eruption happening in Iceland, so that's forming now.
Oh yes. Yeah, I actually, it was an almost spiritual experience for me. Not just that there's a volcano erupting, but being able to just follow a live stream. And I told you before, we had the live stream on the big TV the whole week, like a kind of screensaver. And I was trying to practice timefulness because I was occupied with some other things. And then I look, it's like, there's actual fire coming out of the earth, and then you saw people picking up rocks. So of course,
sedimentary deposits take some time to convert from loose particles to actual rocks, but they're in the process of becoming rocks. And there are sadly places where people have actually begun to map anthropogenic rocks that have both natural sedimentary constituents and bits of plastic in them on beaches around the world. So yeah, rocks are forming right now.
And have you ever been to a volcano, an active volcano?
Not one in eruption. I've been to Iceland several times and seen, relatively recent volcanic rocks, but I haven't ever witnessed, an eruption in real time myself.
It's probably because because I was preparing for this. Maybe if you want to buy a red car, you start to see red cars everywhere. But just in the past week, we had a volcanic eruption, an earthquake off the coast of Japan, and really heavy rainfall in Australia, which is causing floods. So is that normal, or is it just because I notice it now?
This is what Earth does. Earth doing what Earth does. And it's just we humans who think that it's passive and can most of the time ignore the backdrop. But this is what Earth does. And I love the fact in Iceland that the eruption right now is being celebrated. It's not being viewed as some cataclysmic event, natural disaster. It's, there's been sort of joyful embracing of the dynamic nature of the Icelandic landscape. So I think the perception of nature as passive is a big part of our problem. Environmentally, we expect everything to remain the same as it always has been, and not realizing that nature is paying attention to what we're doing. And if we push it in one direction, it'll push back against us. So we've strayed from stage 2 a little bit, but I think the climbing out of the cave time was this fascinating period of a glimpse of the infinite.
Yeah.
And setting down some rules for how to investigate the Earth. And by the middle of the 1800s, geology had become a distinct intellectual discipline. The founding book was by Charles Lyell called Principles of Geology. It was widely distributed. Lyell was an indefatigable lecturer. He came across to the United States at least once and would come far into the heartland, the frontier at the time, and gave lectures at opera houses and apparently to packed audiences. And so there was this real excitement, I think, at that time about the potential of geology to reveal these lost worlds. But then we kind of stray from the allegory a little bit because, or maybe not, you can push back on this, but then geology, because it started to become a threat to older worldviews, especially about the role of humans.
Well, what Plato writes in the Allegory is, in this stage, all the prisoner wants is to run back to his old seat. So in the old seat, you have the world which is familiar. You don't have a reference point outside of it. And when the prisoner is not voluntarily going upwards, but he's dragged upwards, at that point, they know that there's the reality as they knew it is not as they knew it. There's more, but they don't have a new model to replace it. I guess you could say, well, if what happens a lot if you start to ask questions in a worldview which is already very established, is that they say, well, okay, you ask these questions, but what's your solution? How do you see this? And maybe you don't have an answer to that. But if I follow you correctly, there were some indications that maybe things were not the way we thought they were, but not necessarily a new model or a new answer.
Well, I think when the implications of a really ancient Earth, and in particular evolution that included evolution of humans, that really was the thing that shut down the early promise of geology to some degree. So when Darwin, who was hugely influenced by Lyell, who I just mentioned, and took that Principles of Geology with him on the voyage of the Beagle, when he suggested that evolution by natural selection had created all of the organisms on Earth, including humans, this really struck at the heart of the stories we'd like to tell about ourselves as being special and created by a God who had direct intentions for us. So at that point, geology fell from grace to some extent, and there were powerful forces, including the great physicist of the day, Lord Kelvin, who was the founder of thermodynamics, which none of us can, escape the reality of thermodynamics. But he, in his time, didn't realize that the Earth actually had two kinds of heat, primordial heat and radiogenic heat from radioactive decay in the interior of the Earth. And he said that the Earth, like all other things in the universe, had to be dying a slow heat death. And he made a calculation about the age of the Earth that was based on the assumption that the Earth had just steadily cooled from a molten state to the modern state. And if you make that calculation and you measure heat flow coming off the Earth today, the Earth looks really young because the Earth is really hot. So using his logic that the Earth had started as a molten ball is cooling down, and the fact that the Earth is actually still pretty hot today, he concluded Earth couldn't be more than 20 to 40 million years old. And it's become clear, and that's, an order of magnitude, at least 2 orders of magnitude off. It's become clear in relatively recent times from letters he wrote that he was actually quite adamantly opposed to Darwin's theory of natural selection, that he may have had ulterior motives. He was a great scientist. There's no dismissing that, but he seems to have had some non-scientific motives for questioning Darwin.
Yeah.
And that really set geology back up. I mean, I can't emphasize that enough. It was just such a blow. It's interesting to me that geologists in the 1800s, when there wasn't any way to actually measure absolute ages of rocks or durations of times, had some instinct that the Earth had to be on the order of at least hundreds of millions to billions of years old. That's really interesting to me. It means that they were good scientists. They were developing some kind of intuition about the processes and the rates of processes.
And maybe an absurd thought at that time, which was given by close examination of, following the logic, following the reasoning, but also paying attention to the rocks and to all the other processes.
Yeah. But then to be told by the towering intellect of the day, you stupid geologists, you're wrong. It just created, I have this visceral empathy for that group of geologists. It must have been such cognitive dissonance. And for Darwin in particular, he said that Lord Kelvin was his sorest trouble. And, he really was devastated by this, and he never could understand. He felt in his bones he must be correct about his theory. But again, to have this just eminent physicist really scornfully dismiss his assertions was devastating. So geology then, I think one of the unfortunate artifacts of that is, and this is that kind of doldrum time I was talking about when you asked the question of if geology were a person, what sort of age would they be? The doldrum time came when geologists, because of this friction with Lord Kelvin, kind of decided to just become their own group of scientists. And they became very distrustful of other sciences, which is a dangerous thing. And many geologists were therefore not well trained in mathematics or chemistry, which today, that's just absurd. We need the tools of these fields to understand the very complex Earth system. But an unintentional, long-lasting artifact of that whole thing with Lord Kelvin was this deep distrust. And I think that really set geology back, because then you had people who really weren't very good scientists for a long time, trying to understand things that were incredibly complicated and didn't really have the quantitative tools to do it.
I just like to ask you one other question before we go to the surface, because there's a hugely intellectual component and a lot of arduous work to geology. At the same time, if I'm reading about a discovery that you write that there have been earthquakes larger in magnitude than any experience in human history. And you, I think the movie is the Day After Tomorrow. Of course, in the movies, they try to, use the biggest dramatic effects. And you said, well, it was nothing compared to that. I experienced 2 earthquakes in my life when I was in Nepal. It was 2 of the aftershocks. And I can appreciate also the intellectual side, but it was also an almost spiritual experience. It was, it's such a deep, I can't really, I'm trying to find words. I cannot find words for it. And then I turned around and I saw these Nepalese children that had lost family because of these were just aftershocks. Mm-hmm. So how do you deal with that, with kind of having a clear-eyed view of the earth and what's going on now and what could happen? And when we have people like Greta Thunberg screaming, like, what are you doing? And at the same time, I can completely understand why people don't want to face the reality of climate crisis, because, well, it's I work in medical education, and there's a lot about doctors have, and patients when they learn they're going to die, and the difficulty they have facing that, and how human beings are. It's very difficult to face, these kinds of existential issues. And I just wonder, how do you deal with that on an emotional level if you're busy with it every day?
Yeah. We aren't good at looking our own mortality in the eye, either in, as individuals or as collective. And I guess one response I have to that is that my intellectual study of the earth is actually a source of deep existential comfort to me. I have a sense of embeddedness in this place. I understand that I am another earthling, and there have been many before and many to follow. The sense of being able to read the earth narrative is comforting. I think for me, early on, when I happened into the study of geology in college, the thing that really attracted me was the explanatory power of geology. Yeah. I use this phrase in my teaching that geology is like the etymology of the world. If etymology is the story of a word's origin, geology is the etymology of everything around us. And to me, that has this kind of comforting power to it. And I think that is why people are so reluctant to leave religious narratives, because those are narratives that explain why things are the way they are. Yeah. Unfortunately, many of them, to me, are incredibly cartoonish and oversimplified and blind us to the much richer, deeper, more subtle story. And there are going to be more earthquakes and more volcanic eruptions. There are going to be large magnitude climate related weather events. The climate related ones are our own fault. We're going to have to learn to grapple with those, but there's absolutely no reason to continue to be shocked, no pun intended there, when a great earthquake happens in tectonically active places. We should wake up to the fact that this is the way the earth works, and we should just learn to live as best we can with that.
So one of the things that people said about Nepal is that the first thing we have to do is to build, of course, people live in very poorly constructed houses there a lot. And there was an effort at the time, which was that 2005? Or was it
the Gorka earthquake?
The last one. 2015. It was 2014, 2015. Yeah. Mm-hmm. So that hasn't happened. So just to be clear that the next earthquake is going to come, and many people are going to die there without any need.
Actually, one of the catalysts for writing timefulness was that I too had experienced an earthquake in 2016 in Italy. I was teaching in the Apennines, and there was an earthquake that devastated the town of Amatrice in the Abruzzo region. I don't know if you remember that. About 300 people died. It was not a terribly large earthquake. It was about magnitude 6.5. We were maybe 30 or 40 kilometers away. But I was teaching about mountain building and tectonics, and it was an unintentional teachable moment. But there too, Italy is Italy only because it's on an active plate boundary. Earthquakes and volcanic eruptions are part of the story of the building of that region, and yet there was this how could this happen? And it was just another illustration to me of how willfully blind we are to the earth beneath our feet. Why can't people say, okay, this is the way the reality is. Let's build better. Let's learn to live with this very active earth.
Yeah. You speak about religion, and a lot of religious thought, at least in Western, has also been influenced by a certain reading of Plato's Allegory, the Platonic ideas. And in the first episode, we already started to make clear that this is not, there are many different readings of the cave. So there's one reading, but you also speak about physics in relation to Platonic ideas. In Timefulness, you write, I quote, "Their designation as the pure sciences is revealing. They are pure in being essentially atemporal, unsullied by time, concerned only with universal truths and eternal laws. Like Plato's forms, these immortal laws are often considered more real than any specific manifestation of them." What do you mean by that?
Well, first of all, physics, I think everybody kind of understands, is the priesthood of science. Mm-hmm. That there is this kind of hierarchy. And so that's really interesting. Why is that? Physics deals with these things that have claimed to be outside time, essentially. And so I'm not a scholar of Greek philosophy, but I'm familiar with this sort of schema of the Greeks, that there was the earthly realm, and then there were these concentric spheres outward from the mundane earth that were progressively more perfect, and their perfection came from being unchanging, whereas the earth was kind of corrupt and somehow less further because it's constantly changing. It wasn't perfect. So to be perfect was to be unchanging in the Greek mind. So I think science got picked up on that early on. And in Western science, there is this attitude that the things that have the greatest universality are the best or the most prestigious sciences. And the things that deal with messy details rank lower. And I think that's just wrong-headed. Again, I have this kind of fantasy of a different path out of the cave, I guess, for the geosciences that could have happened at that critical time of emerging in the 1830s or so, if only maybe Darwin, Lyell, and Humboldt had been more nearly contemporaries and had more opportunity to interact. There could have been a parallel growth of physics and a more holistic kind of natural science nexus, where the methods of physics, which are these kind of universal things, and the methods of the biogeosciences, which have everything to do with time, could both have flowered. And there's an environmental scientist named John Hart, who has a wonderful short paper that people can probably find. It's called Integrating Darwinian and Newtonian Worldviews, or something like that. No. And that's exactly what I'm talking about, that there's the Newtonian way of thinking about the cosmos, and there's the Darwinian way, which celebrates rather than denigrates evolution over time and the flowering of all kinds of possibilities from small differences at the outset, whereas physics likes to distill things to these very simplified, stripped down idealizations, and would consider all of those evolutionary manifestations just kind of messy, degenerate examples of some perfect thing that actually doesn't exist. And we need both. We need both.
What you say is also raised by a lot of physicists. It's also an internal conversation in the discipline. For instance, Sabine Hossenfelder wrote this book, How Beauty Led Physics Astray, where she argues that the choice for which theory or which hypothesis or where to invest money, for instance, the Large Hadron Collider, is often led by an appreciation of the beauty of the mathematics, and perhaps also the idea that that there's a harmony there. That's which I would say is it's a certain harmony. But in your book, how you describe the autobiography of the Earth, it's so incredible how we talked already about the balance between erosion and mountain building, which if it were just a little bit different, the world would be a different place. I don't know if we would be here. But could you speak perhaps a little bit, if the old Platonic form is something that I would say we humans think up, we think, oh, this is how the world should be, and we try to impose it. How would you characterize the Earth or the processes that happen on Earth?
In a Platonic way?
Well, for instance, if I want to think about Earth, we can say, well, the Earth is a planet. Okay. But then we have the idea of round, rocks in the sky. We can say it's a system, or it's an organism, or perhaps it's a mother Earth. That's just what I can come up with. But how? I'm not sure if I make myself clear. But is there one idea about the Earth that you have that best describes how we should see the Earth, or is that impossible?
It's all of those metaphors that you mentioned and more. It's so richly layered, literally, but also just in the myriad systems embedded in systems that I don't think there's any one image or avatar I could come up with. I do sometimes, when I try to characterize what geology really is about to people who have the perception that it's about digging up dinosaur bones or exploring for oil, I try to convey the idea that the Earth is really a system of processes, and those processes are remarkably commensurate with each other. So that's sort of the theme that I develop in Reading the Rocks, is these kind of equal and opposite tendencies that Earth has learned to balance. It's not just this, but it's also this, and the kind of Tao of the this and the that have kept Earth stable. For years, certainly as a student, I was always told the Earth just happened to be the right distance from the sun. It's just the right size, and what a lucky rock it is. And I think, well, that's true. That gave Earth a chance to become what it's become. But it's the habits that the Earth has developed over time and maintained over time that are really the remarkable thing. There are probably quite a few of the exoplanets that we've glimpsed out there that are about the same size and about the same distance from their stars. But I am skeptical that there are very many of those that have the particular combination of processes that are like what we have on Earth.
Because you also it's not just a matter of imposing one order, but you describe how there have been at least 5 major catastrophes where actually in one case 90% of life just died out. In another case, the Earth turned into a snowball. And you describe how they sound like near-death experience of the Earth. And still the Earth recovered over and over again. So I think there's hope for the Earth, at least.
Absolutely.
Sometimes people speak about life will end, or oh, poor Earth. What's going on at the moment. But for the Earth, I think we'll be fine. I think there will be something new happening.
It's very robust and very resilient. And at least the microbial world is also. Microbes have been and always will be in charge. And if we didn't believe that before, certainly the COVID crisis has made that clear. But yes, Earth has so many amenities. I mean, ranging from the magnetic field to all this water that we have, and then life has become part of that with biogeochemical cycles, which sadly people just do not appreciate the services that biogeochemical cycles do for us. And we are outlaws essentially in disrupting those cycles in such a way that we are now threatening our own existence. So, yeah, Earth is a very amazingly strange planet, and I wish more people could appreciate just the unlikelihood of all of these things converging in the way they have.
Yeah.
Yeah.
In the Allegory, Plato says that when the prisoner comes to the surface, he realizes that the sun is what grants both the seasons and the years, and what governs everything that is there now visible in the region of sunlight. And moreover, that the sun is also the cause of all those things that the people who dwell below in the cave in some way have before their eyes. So the sun is basically the source of everything we see on Earth. Do you agree with Plato?
Absolutely. The solar system, which is, of course, named for the sun, is by far dominated by the mass of the sun. We, on this little rocky planet, are just a tiny fraction of the material that went into the building blocks of the early solar system. It's very special material. But we are pieces of the sun, basically. The planet was built from materials that are very similar to a type of meteorite called chondrites. And if you exclude hydrogen and helium, which is what most of the sun is made of, and look at the ratios of other elements in chondrites, they basically have the same composition as the sun. And that is thought to be the composition of the Earth as a bulk system. The prisoner is also correct in that almost all life is based on the sun and photosynthesis. There are a few other strategies for making a living on the surface of the Earth, but for most of us, photosynthesis is really the basis. And that's been around for a remarkably long period of time. The very oldest hints of life on Earth point to photosynthesis as the metabolic mechanism for survival. So it makes sense. This is a huge source of energy. And so very early in life's history, it learned to tap into that energy. And we in the 21st century should take note of that. Mm-hmm. I call the affinity for the sun heliophilia. Certainly, I start feeling that here in Wisconsin at the end of the
I'm looking forward to the summer here as well.
We're all heliophiles.
Yeah. So if we are at the sun and we see whatever understanding we have of geology at the moment, what do you think are some of the key insights of geology at the moment that we should take back with us into the cave?
Well, I think what's emerged in the last 30 years in particular is this sense that all of these different components of the Earth are connected in ways that we weren't thinking about before that. So my field of structural geology is most allied with geophysics and rock mechanics. And it's been recognized relatively recently that mountains, their growth, due mainly to tectonics, is actually strongly influenced by climate. So if you're building a mountain belt but it's also being eroded even as it's building. The internal architecture of the mountain belt will be different depending on whether you're in a rather arid region where erosion is slower versus a very wet region where erosion is much more efficient. And this is because you can only kind of stack piles of rocks so high before they start kind of collapsing on themselves. And so the pile of rock that's accumulating is going to be a function of the climate system. So we used to kind of think that we could ignore things that were going on at the surface of the earth. We're studying the crust of the earth. And now we're saying, oh my goodness, these things are entangled with each other. There are feedbacks between parts of the Earth system that previously had been studied by completely different kinds of scientists.
Yeah.
So we're having so many more cross-disciplinary conversations. The same is true for all these biogeochemical cycles I've been talking about, that we think of erosion again as this kind of physical thing, but clearly it's accelerated by the chemical action of organisms. Probably, granite would not break down even a tenth as fast if it weren't for microorganisms living in rocks. So to me, this emerging into the sun that's happened has been this reintegration, kind of going back to those early days of geology where people were just open to the whole organism. And then we went into this time where everybody was just myopically looking at slivers. And now we're able again to begin to see the glory of everything connected. And it's non-trivial to even know how to begin. We need new methods and lexicons and instruments to measure these things. That's great. It's a heady time. But again, the public perception of the field is kind of stuck in the 19th century, I think.
Yeah.
And it's more urgent than ever that people who live on this planet actually begin to have some sense of humility at how complex it is and how, while it is robust and resilient, it's not inert. It's dynamic and it responds to changes that are imposed.
So one of the ideas that people have about geology is that it describes very slow processes like the movement of tectonic plates, which are maybe, a couple of centimeters. Maybe the sea level is rising a couple of centimeters. Maybe the temperature is rising a little bit. And in the Netherlands, we just had an election and you hear, the temperature has been changing all the time, fluctuating for the last few thousands of years. So I just want to ask, as a geologist, what you see happening geologically, is there any place in the past of the Earth that you could compare it to? Has the Earth ever been in a situation like this before?
Probably the closest analog is this event about 55 million years ago called the Paleocene-Eocene thermal maximum, which is a terrible long thing. So people call it the PETM. And it was caused by the sudden release of some kind of hydrocarbons, obviously not due to fossil fuel burning, but either the ignition of coal underground by perhaps volcanic activity, or the belching out of the seafloor of frozen methane, what are called clathrates or methane hydrates. Anyway, it's a very large volume of photosynthetically fixed carbon was pumped into the atmosphere quite suddenly. You can't say quite how suddenly, maybe in a couple of days or maybe in 1,000 years. Can't resolve that. And it caused a very abrupt spike in temperatures. It caused acidification of the oceans. We see just disappearance of a lot of calcified shells in rocks of that age. And it caused a small mass extinction that included of deep sea organisms, small organisms, telling us that probably the deep oceans warmed up for a period of time. So there was a real upheaval, and there was also rearrangement of land ecosystems. And it lasted tens of thousands to 100,000 years.
Okay.
And that's a disturbing event. It was a time when carbon dioxide levels in the atmosphere were already quite high. There wasn't a lot of ice to melt. And so maybe the carbon sensitivity of the Earth was not as great as today, but still it was very disruptive. And so lots of people are studying that event as a distant analog. The biosphere was somewhat just different than it is today.
Yeah.
Humans did not exist, obviously, but it seems like something close to what's happening. The problem is we can't, again, quite resolve what's the denominator in terms of rates, because we don't know years or thousands of years.
So if we had been living at that time on Earth, what would have happened?
Well, we would have seen temperatures jump by something like 8 to 10 degrees Celsius over probably a decade or something like that, and remain high. We would have seen areas that had been quite lush in vegetation become very arid. We would have seen the extinction of plant and animal species on land, and the base of the food chain in the oceans disrupted quite severely. Mm-hmm. And again, the biosphere is resilient. Plants and animals evolved, but the reestablishment of equilibrium probably took something at least on the order of 10,000 to 50,000 years. That's a long time for humans.
Yeah, and you point out in your book that, I'm just going to read the quote, our advanced technologies make us less flexible than previous societies in the face of change. We have made huge infrastructural investments in coastal cities based on a bet that sea level will remain constant. We have built sprawling cities in the desert on the assumption that snow and rain will keep refilling reservoirs. We have a food production system that is predicated on the belief that old familiar weather patterns will always return. But the weather is getting weird.
And in the Netherlands, I mean, you're acutely aware, you've always been aware of the sea.
Yeah.
And we are playing with fire, literally here. The Holocene has been an unusually stable time. This is 10,000 years is the Holocene. The last 10,000 years, human history is really kind of an anomaly in terms of being quite stable climatically. Mm-hmm. And now we are setting in motion feedbacks that could really destabilize this otherwise quite clement period we've enjoyed, and during which it's been possible for civilization itself to grow. So certainly, yes, the Earth's climate has changed in the past, but we weren't around, and certainly not modern societies that really are predicated on things being the way they always have been. They weren't around during these times of great fluctuation.
Yeah, as I said, we just had an election in the Netherlands, and currently they're forming a government. I don't know if anybody of the government listens to this, but you had this really great idea, I think, of what we should do. The Secretary of the Future. I actually started sharing on social media that maybe in the Netherlands we should appoint a Secretary of the Future. What would the job of this person be?
Well, and first I should credit, it's not my idea, it's Kurt Vonnegut. And secondly, since the book came out, people have written to me and pointed out that there is a Secretary of the Future, at least in Wales, in the UK. The kind of regional government of Wales does have such a Secretary of the Future. And in that case, the person is at the table anytime major decisions are made. So one of the criteria, not merely economic analysis, but what will be the effect. I'm not sure how far in Wales they project into the future, but any proposal has to be viewed through the lens of future generations. And that's the job of that person, is to speak for the not yet born in ways that we generally don't do. I mean, certainly in this country, we are so locked into the presidential election cycle and the congressional election cycle. It's very difficult for any kind of conversation that has a view that's more than about 2 to 4 years into the future. And corporate decision-making is almost as bad. Some corporations do think on decadal timescales, but most are just kind of wrapped up in the quarterly or annual report cycle. So we don't have any kinds of mechanisms or formal administrators whose job it is to say, wait a second, what are the implications of this in 10 years, in 20 years, in 100 years? And that would be the Secretary of the Future, to always be seeing things through that lens and not allowing the tempests of the moment to constantly be dictating our decision making.
Well, I've certainly hoped this will happen in many governments because, as you write in your books, we need to start to change our relationship to time. If people are wondering, because these are such big issues and we're so small, and what effect can we have on the global climate? I think I completely agree with you that it starts there, our relationship to time. But it can be overwhelming. Can you suggest some small ways that we can start to integrate timefulness in our lives? What can I do tomorrow? What can I do next week in my life to start to integrate that?
Well, in the Netherlands, there's not a lot of rock outcrop, is there?
No, we don't even have mountains. It's completely flat.
But you have a geologic story, certainly. And the human story has been very much wrapped up with that of draining areas to reclaim them for agriculture. But learning the story of the landscape where you are, where everyone is in the world, I think is a good start. These are the places that you know well, or that one knows well, and understanding the backstory. Why is the landscape the way it was? Increasingly there are very good public resources online from geological surveys and popular books about particular places. Just getting to know the kind of idiom of the local landscape is a good start.
Yeah.
Then that can be a scaffolding for building out further. But I think it's kind of like learning the names of the birds or the mushrooms or the plants in your area. Learn to have some kind of conversation with the landscape and learning to read its contours. Yeah. That can be the start. Then you see that it's not always been this way. Oh, this area was under the sea at some time, and now. Mm-hmm.
Yeah, and it can be. I think it's sometimes people think, well, but I'm a lawyer or whatever. But I think it can be. Personally, my day job is in medical education, and we started a conversation there about climate change, and perhaps climate awareness should be part of medical curricula, because healthcare is one of the big factors on the climate. And if you have, for instance, if you have the possibility to prescribe 2 therapies to a patient, and one is like a medicine with a huge carbon footprint, and the other is, I don't know, yoga or something like that, and they're both equally effective, then maybe those are also small ways to start. And you sent some clips, some films to start to maybe visualize some of, because that's the main thing I was struggling with your books. It's like, if I was speaking to a mathematician right now, they're able to visualize mathematical formulas and everything. You apparently can visualize these geologic processes. You're able to think in 4D. How can these little clips or these movies help us with that?
There are a range of things, from maybe familiar depictions of plate motions to some really beautiful scale models that are done in sand that actually are quite good at replicating features that we see in mountain belts that allow us this kind of God's eye view of mountains growing over time. And then there's a really lovely stop action film. It's from Germany, that's in English called The Rocks. And it's just a very nice depiction of how rocks might perceive human time.
Well, thank you very much for speaking to me today and being our guide through Plato's cave, taking us out to the surface and bringing us safely back home.
Actually, I'd rather stay up on the surface, if that's all right.
That's all right.
Thank you, Mario.
And thank you for listening. I recommend Marcia's 2 books, Timefulness and Reading the Rocks, and a third that will come out in 2022 called Geopedia, a Cabinet of Geologic Curiosities. I will link it in the description. There you will also find links to some movies that help visualize geologic processes. Your homework is to find out about the geologic past of the area where you live, and to watch the live stream of the Icelandic volcano for at least 2 hours. Oh, and to solve the climate crisis, but I don't expect you to do this before the next episode. For other episodes and ways to support the podcast, check out livefromplatoscave.com. I also want to thank Julian Penning of Live One Art for creating an illustration for each episode. One more thing. As we discussed, earthquakes and other natural disasters can be traumatic, especially without a timeful narrative to make sense of them. Perhaps this is even more so with another type of disaster, a social one. The Holocaust is an example of such a traumatic event that shook the world to its core. But what exactly is trauma, and what can we learn about so-called normal experience from studying it? That's what we'll talk about next time.